Good evening, everybody. Welcome to Extra Mind. Today, the topic is actually on Numpy. So, the first topic is on Numpy, then we will go to Matplotlib. So, Numpy is actually an array processing package in Python, and for importing the Numpy, you have to import using the import keyword and import NumPy as NP. So, NP is nothing but it is the alias of NumPy. So, in place of NP, you can write anything of your choice, but mostly you can see that it will be written as NP itself. So, NumPy as NP, we have imported the package. And the second is I have just created one array. This is a one-dimensional array, and you can see 1 2 3 4. This is the one dimension. If you want to check the dimension of the array, ARR is the array, so you can check the dimension using ndim attribute. So you can see that it's 1 because it's a one-dimensional array. And if you want to create a two-dimensional array, or you can say it's some matrix, then you can go for ard equal to np.array. np.array, this is how you create a 2D matrix. So after printing this array, the matrix will be formed in the form of rows and columns. And if you want to check the shape of the matrix is 3 by 4, means 3 rows and 4 columns. And if you want to check the dimension of the array, the dimension will be 2D. It's a 2D array, so the dimension will be 2. It's very easy to work with arrays in Python programming language. And if you want to transpose the matrix, then just the matrix dot t, it will be transposed, means the rows will become columns and the columns will become rows. Now one more function is there inside NumPy, and that is called a range. So it takes three parameter. One is the starting, and the last one is the ending, and the third one is first one is the starting, the second one is the ending, and the third the last parameter is the steps. So when you print this variable a, which contains the values, so it will print from 0 till 25, because it starts from 0. A range actually starts with 0, or whatever the range you have given over here. It starts with that, but always goes one line, one less than the prescribed value. Means it will start from 0 and it will go till 29 with a step of 5. So 0, 5, 10, 15, 20, 25. This is actually the conclusion with a range. And the second one is lean space, as the name suggests, linearly spaced. Okay, so whenever you give a np.lean space itself a function inside a numpy. So I have written np.lean space. The same thing if we have given, 0 is the starting and 30 is the ending. So you can see it is starting from 0 and it will end at 30 itself. Provided inside between this, it will give you 15 linearly spaced number, means including 0 and 30, 15 linearly spaced number will be given. So you can see the total numbers here counted will be 15. That means the difference from 0 till 2.14 is 2.14 itself, and from 2.14 to 4.28 is 2.14, and for from 4.28 to 6.42 it's 2.18, from 6.42 to 8.57 it's 2.18, from 8.57 to 10.71 it's 2.18, something like this, 2.14. Okay, so all the numbers are basically linearly spaced. So a dot length space. And if you want to find the power, so 2 stars will be given, because star stands for multiplication and 2 stars stands for power. So yeah, I have written here 5. So whatever the values that are present inside the ard array, every value will have the power of 5. Okay, and here we will have x, that these are actually the value of x, and here we have the value of y. Okay, and here we have the resultant matrix. That is actually whenever you want to multiply two matrix, and the matrix is of 3 by 3 itself, 3 rows and 3 columns. So ultimately the result will also be a 3 by 3. So by default I have taken the result as a 3 by 3 matrix, and all the elements are actually formed with filled with 0. I run a row for the length of x, and the length of x is 3, and I run columns for the length of y. The length of y is also 3, right? And I run k, a loop with for the length of y. Now what is the length of y? The length of y is 3. Okay, and here in case of column, I have written here length of y0. Y0 means the element inside this first element. Okay, the first matrix, first row. Okay, so there will be 3. It will be 3. Now when I just multiply the row by column, and just I need to add the result into the rows and columns, and after the results has been added, it's a simple like the multiplication of the matrix that we used to do on pen and paper. So if you just compare the and recall the formulation of how we used to do a matrix multiplication on pen and paper, the same thing has been followed here only, but with the help of loops. And once the result is we are getting the result, once the result is published, you have to run a for loop through the results in order to print all the elements. Okay, otherwise you cannot directly print result, because you have to go through a for loop. This for loop is actually going to iterate through the whole array. That means the result, it is going to iterate through the whole result, and then it's going to print the value. So this is how the matrix multiplication takes place. And here also the same thing. Here also we did a matrix multiplication here, and a dot product. You can directly find the dot product with the help of the dot function. So you just need to pass two parameter. One is the first array, and the y stands for the second array. And if you want to find out the cross product, then the cross product also, there is a function called cross, and you have to pass the parameters. The first one is the array, and the second one is also an array. So all the two arrays are, one is stored inside x and the other one is stored inside y. And if you want to replace an element, like suppose the art, where is the art? If you see, this is basically the art, the array. Okay, so this is actually the elements. Now if you want to replace any of the element, you have to just provide the rows and columns. So first row means 0th row, and this is the 1th row, and 2th column means 0th column, 1th column, 2th column. So this element we are going to replace. So we have replaced that element with 500, and once you print art, you can see that the element has been replaced with 500. Okay, the element has been replaced with 500. If you want to find the inverse, basically the inverse, it's very easy. For that there is a function called lean-alg, right? It's a sub package inside numpy, and inside that there is a function called dit for finding out the determination. So if the determination of the sq, which is itself an array, it's an array of 3 by 3. So if you find that the determinant is not equal to 0, then we can definitely find out the inverse. So np.lean-alg.inverse of the square means inverse of this sq. Sq is actually nothing but it's an array, and we just print the inverse, else we will say that inverse is not possible. This is actually the exception case we have given, that if the inverse is not possible, means if the determinant is 0 equal to 0, then you cannot find the inverse. Na? So that's why we have basically written this else part. Now we have import a random for generating some random number. I have imported the random module, and random.randint 0 comma 100. So it will give you a integer random number between 0 and 100. So if you run it multiple times, you can see that every time you run it, you will get some different random number. So x equal to random.randint, but it will always give you integer value between the prescribed range. That means between 0 and 100. Okay, between 0 and 100. So it's going to give you a random integer value. So here we are getting 39. So you can see that if I just see whether it is connected to the runtime environment or not, it takes some time to connect to the runtime environment. So you can see right time I was getting 95, and if you run this once again, so you will get some else other variable, like you are getting 11. So integral value every time. And from numpy import random. So now if you just write here random.rand, so it will give you a random value, that is a float value between 0 and 1. Always it will give you a float value between 0 and 1. Okay, it will give you a float value between 0 and 1. And if I write x equal to random.randint, if you want to generate the value basis on the count, like from between 0 and 100, if you want to derive 5 random values. So you can see here, you can pass the size as 5, and here you will get the values. Here you are going to get the values, 5 random values. Okay, if you run this also, you will get different values each and every time. So it's actually the size equal to 5. So random.rand, you got an unexpected keyword, that is argument size. uh, okay, so why you are getting an error? We should not get an error. So random.rand, it got an unexpected keyword size. Unexpected keyword size. Wait just a second, let me run this particular example. Here we are creating between 0 and 100, we are creating a uh, import random. Okay, so we are making some mistake. I think I from numpy import random. Wait, from numpy import random. So these cells we didn't run. We didn't run this cell. That's why it is actually causing a problem. Now you see, you will get the output. You'll get the output. Okay, so we were unable to. We didn't run this particular module. So from numpy import random, this module you have to run. You will get no error. If you want some random float values, okay, so we have passed a value of 5, so you are getting 5 float values. And if you want to get a 2D matrix of like 4 comma 5, means 4 rows and 5 columns, so you can get some random values of matrix 4 by 5, and that is also a float values. If you want to create a random matrix, if you want to create a random matrix of your choice, okay, or so you can directly create it like this. But here basically the choice function is actually getting some value. getting some value from this particular available options itself. So we got it 9. And in this choice in the second one, you can see that we are having a size of 3 comma 5, means we are going to create a matrix of 3 rows and 5 columns, but with the available values over here. Only these values are going to take part. So you can see here we have concluded this as a matrix with the help of choice. Okay. And the last example that is we are going to do today is actually using the Matplotlib. Now, what is the Matplotlib? Matplotlib is a 2D graph plotting library. It's a 2D graph plotting library. So you can see here we have imported matplotlib.pyplot. Pyplot is nothing but it's a sub package present inside Matplotlib as a PLT. It is actually the alias. So we have applied this x, which is actually itself an array, and similarly y is also an array. And plt.figure, we are creating a figure size of 8 by 4, means on x-axis it will take 8, and on the y-axis 4, that is a half of x. I have given a label to the x-axis, I have given a label to the y-axis, and I have also given a title to the graph. So you can see that we have a label of x-axis is time, y-axis is distance, and here we have the title as graph. So if you just plot it, plt.plot, and you just pass the first parameter as x, the second parameter as a y, and the line width at 0.9, and the line style is hyphen hyphen. Line style is hyphen hyphen. The color is red, and the alpha is actually for managing the color contrast. Okay, so we are also using grid axis both. Okay, so you can see here we have applied the use of this plot. The plot is always going to give you a single line. It's going to give you a single line. So you can change the values in order to get different graphs every time. But always you are going to get this line plot itself, because the plot function is actually going to give you only the line plot, not anything else. If you want to go for some other plot, then you have to change that plot to bar. If you just plot it to bar, then you are going to get a bar plot. Okay, but here some parameters will change, like the width I have given as 0.5. This will basically control the width of the bars, and the alpha is basically same. The edge colors is red, so you can see a light edge color is actually given over here. And the line width, the width of the line means the width of the lines which are given by the given around the edge color. Okay, the edge color lines width is 0.3. If you want, you can create much more also. PLT.show. Right, and plt.figure, here you can see x label is time, y label is the distance, and here I have given a scatter plot where I have used the make the use of the marker. So marker I have given as a star, so you can see the graphs are basically plotted in the form of a star. And s is 100, means s is actually the size, it is related to the size. So more you give the value of s, more bigger will be these stars. So this is nothing but the scatter plot. So here the function is the main, that is scatter. So like previously we have for bar plot we have bar, and for line plot we have plot. Okay, so it's totally depends upon the functions that you are using. You need to remember this function. And here I have plotted a pie chart. So you can see here also that we have a pie. So we have some students, which itself is a list, and the second is we have a course, which is also a list. And we have written plt.py. The first parameter is the students, that is the number, list of numbers, and the second is a labels equal to course. So labels is a predefined, which is attribute which is actually going to put a label on this pie chart. And inside labels we are passing this particular list, course list. Auto PCT is actually converting these numbers into automatic percentage to 2 decimal place. So that's why we have given auto PCT. Shadow is true, and the start angle is 90 degree. You can see the graph is actually starting at angle of 90 degree. And explode we have given all 0, and only one we have given a 0.1. That means you can see this cake like slice is actually cut out. Okay, so the fourth one, that is actually 0.1. So here it is actually 0.1, it is out. You can give 0.2 also. The more value you give, the you can see what is actually going to be the output. Means the more far away it will move from the actual value. And here the colors is red, blue, cyan, and green. Okay, so you can change the colors also as per your choice. And which props is actually the edge color. We have given the edge color is actually as a black, and we have given plt.show to display the graph. So this is basically the pie chart. And next we have the histogram. For histogram you can pass some random values. We have just passed some random values like 250 random values basically. Okay, so 250 random value has been generated from this for this histogram, and you can see the histogram is actually getting plotted this histogram, right? So histogram is very easy, because we need to do we need a lot of number in order to plot the histogram. So we have directly taken it uh, from the module itself. uh, and that is actually already present inside the numpy. So normal is actually used for this normal function is actually used for Gaussian distribution. Okay, it's used for Gaussian distribution. Now it has taken 3 parameters. So the basically it's taking 3 parameters. So whenever it is taking 3 parameters, the 3 parameter is actually has some values, right? The normal function it's actually used for normal data distribution, right? The normal data distribution. So we can see that the scale is actually 10. This middle one is actually stands for scale. This one stands for scale, and 170 is basically the mean. It's the mean where the peak value, the peak is of the bell exists. Basically, the peak of the bell exists basically. Okay, at 170, and 250 basically represents the size, means the shape of the array, which is basically written. So this is the topic for today. If you like the topics, please like and subscribe to the channel. Thank you, everybody. Thank you.